We're getting some fluctuations. There we go. There we go. Yeah. Check that out. Look, my low side pressure's coming down too. Okay, so it's starting to read properly with heat. Cause see the low, oh, this is sweet. Oh, big change, big change. So heat is like making the sensor work properly. And now our actual low side pressure, yeah, look at the fuel pump duty cycle increased and our pump pressure increased. Oh, what a great capture. We don't even have to come back. Can we ask you a question or two real quick? I have bronchitis or something. I'm not contagious. This is like past 2 weeks of this cold, and I have a doctor's appointment at like 12:50, so we got to move quick today. But I just can't beat this cough. I need something. I need something to break up the crap in my lungs. I think it's bronchitis. So I'm not contagious, is what I'm saying. I only feel crappy right now because I took 2 NyQuil last night so I could sleep without coughing, and now I just feel like I'm stoned. I feel like I'm stoned. So anyway, so there's our intro. That's where I'm at.
What's up, guys? ScannerDanner right over there, feeling like crap. So I'll have the energy today and tell you what's going on with this car.
That's awesome. Let's roll with that.
What is it? A Fusion Focus? So it's a direct injected EcoBoost Ford car. That's all I know. It died on her after a long highway trip. Wouldn't restart, ran really bad. Then her son got in it, drove it, said, "There's nothing wrong with it, Mom." And then 20 minutes later, it acted up again. And there was no codes, then an active grill shutter code, which I disabled. It doesn't set the check engine light on these cars.
All right, so that active shutter code's gonna be there.
Yeah, that's the only one that's there.
Okay.
So anyway, after running it the first time I started it up and ran it, I forgot it was running, and I went outside like an hour later. I'm like, why is this car key on and not running? And then I killed the battery.
So it stalled and you left the key on and killed the battery.
I didn't know,
Good job,
so
Danner.
then it was like, a couple nights ago, I was working late. I'm like, well, I'll start it up and I'll walk around and do stuff. Had the scanner hooked up and it started huffing and running real bad. And then I looked at my fuel trims and they were positive 50.
We're gonna try to recreate all this.
Yeah. And I saw my high pressure direct injection fuel rail pressure at 650 commanded, like desired was around 650. And then the worse it start running, my high pressure was dropping all the way down to like 200, and then it started huffing really bad.
With the command still being 650.
Well, I don't know. The command goes up to like 1100 or something, trying to change this, but it's not. So I know I have a fuel issue because of my fuel trims. I know it's a lean issue from fuel volume.
And there's a stalling problem too.
And it's stalling and it runs really bad, but my one concern is my low tank side pressure. They want it 85 and I'm at 109, and I don't know if I
Where'd you get that 85 number?
That was actual desired on the scan
tool. Desired is 85, okay.
And I'm seeing 109, and I'm seeing like a 50% duty cycle on the fuel pump module for the tank unit.
So the tank unit one is a pulse width modulated.
Yes.
For control for pressure.
For pressure,
okay.
And because they didn't match, my only, just because I think too much, is like, well, what if that is wrong? And the 109 is like a fixed number from a bad sensor, and it just doesn't think it has to duty cycle it anymore because it's already higher than it should be. I just don't know if that's just like a scan tool or some kind of issue, or if am I losing the tank side?
We're worried about low side pressure.
Yeah, so I want to prove that before I go to the direct injection side.
I'm not taking this for a test drive. We can get it to act up just by idling. And what I was going to say inside that I forgot is that it takes about a half an hour of run time before it'll do it. So it's a hot engine type thing, and I had Danner start the car before we got here. We're just gonna let it idle and see if we can recreate some of the stuff just while it's idling. All right, so it's a 14 EcoBoost GDI 1.5 liter. It's got 95,000 miles on it. Yeah, there's our lost comm with active grill air shutter module. My brother said he bypassed that. I'm not sure exactly why, I don't care. Battery voltage below threshold. Remember, he killed the battery too. Yeah, all these battery voltage codes. See that was caused. I'm just going right to the engine now. Okay. My 2 high side pressure readings are right here, and my 2 low pressure readings are here. And this is what Danner was talking about, how the desired is 84, but the actual is 109. Low side pressure voltage is 4.82. Fuel rail pressure is 1.17. Voltage 1.18. The fuel pump monitor percentage, that's going to be for the low side. The fuel volume control valve percentage, that's going to be your pulse width or duty cycle of the high pressure fuel pump. And then I have short term here. I could probably pull long term in while we're waiting. These numbers changed up on us when I added long term in here. Our actual pressure is on the left now, desired is on the right for the low side. And now it's a waiting game. Numbers look good on my fuel trim. Long term, short term right now looks good. My brother didn't have to do anything to this at all to make it act up. I misspoke in the last segment. I said fuel pump monitor percentage, 40%. That's not the pump duty cycle. That's the monitored circuit duty cycle. The pump duty cycle is this one right here. Fuel pump percentage, it's 19.1 and bouncing a little bit. That's going to be your low pressure side, I believe. That guy, that pump's running at 20% to provide us with a 109 number. And my brother was concerned about this one. The 109 not matching the 85. Our high sides right now are matching our desired and actual. There's your desired is 691. Actual is the same. Fuel trims look good, long term, short term. Low side pressure voltage. So this 4.82 volt signal right here would be what is giving us this 109.1 number. Again, the fuel volume control valve, that's the percentage of duty cycle that the high pressure pump is running at. That's our dump, our fuel control valve is controlling the high side system pressure. All right, so we're just waiting here, and I'm doing a little bit of homework on the car. I'm just going into fuel systems. I want to read a little bit about this description operation. I'm really interested in the high pressure pump or actuator or fuel volume control solenoid, and whether it's normally open or normally closed. All right, fuel system, variable speed closed loop system, has a fuel pump that operates on 5.5 or 13 volts, depending on load, that supplies fuel under pressure to the high pressure pump. So this is describing the low side of the system. As a high pressure pump, supplies high pressure, low volume fuel pressure to the rails. It has an FPDM, that should be fuel pump driver module, located on the driver's side lower C pillar area. This is very similar to the older Ford systems. I have some info on the fuel pump driver control modules in operation. It's probably a little different. This one's probably on a CAN network, but okay, well that's important though. The FPDM, I wonder if this data parameter we're reading in the engine computer here, the low side pressure of 109.1, if that's being communicated on the CAN or if that's direct to the engine computer. So it does have a fuel pump cutoff, but that's from the restraints control module. If there's a collision, it talks to the FPDM, it shuts the pump off. That's interesting. So I found some stuff on the low pressure side. It's just, I'm in some pinpoint testing just to gather some more information. So I'm just kind of scanning here. It's a couple questions. Is the low pressure fuel system greater than 45 PSI? So they're using that as like kind of your cutoff on which way you're gonna go. All right, so here's what we know, but just by watching these numbers here. Watch my fuel volume control valve percentage as the desired pressure changes when I snap it. Watch it. Desired went up to 1700 there, 1800, 1900. What we see is that percentage increases. So 100% on would be providing higher pressure, and 0% would be providing lower pressure. So I am assuming that this is a normally open valve, that when we turn it off electrically, it's going to give us the lowest pressure, because I was seeing that on a decel. So to make the pressure drop back down, the actual pressure, watch the fuel volume control valve drop to 0 on a decel. See it drop to 0 there? And the reason it would do that, it's going to open that back up to relieve pressure and bring this rail pressure back down. Watch, snap, throttle, rail pressure increased. And then to bring that rail pressure back down, it shuts the fuel control valve off, which means it's open and it's dumping back into the low side of the system. And we should be seeing that in here. I'm with my brother on the 109 number being fixed. That low side pressure should be affected in that we would see pulsing in the low side, because that's what they do with these GDI systems. They dump the high side back into the low side to lower pressure. When you went out, Danner brought a fuel sample over. He said he even took a fuel sample of the car. I guess because he's worried about this low side pump. Mainly because this data parameter never changed and he doesn't trust it. And right now I don't either. And in particular because I'm not seeing any effect on this low side whenever the fuel volume control valve shuts off and goes to 0%, which opens it and drops our pressure. We're dumping that pressure in pulses as the cam moves for the high pressure pump back into the low side of the system, and we don't see those pressure pulses on the actual low side pressure, and that bothers me. I am with my brother on this. This could easily be a low pressure pump problem, and we need to verify it. The low side voltage is never moving at all either. The low side fuel pressure voltage at 4.82, steady just like the data parameter is. Let's pull a wiring diagram for everyone. Fuel pump control module down here. So it's not on a can. This is just like their older ones. It's exactly fuel pump monitor, fuel pump control, FPC, pin 4, yellow, orange, FPM, brown, white, fuel pump power, fuel pump return. So this fuel pump control module controls, this is the low pressure pump, just like all the other older Fords. So then I can tell you guys, if you want more on testing that guy, I have some videos I can link right here. So that means then our sensors are not going to the fuel pump control module. That means these sensors I'm talking about are going to the engine computer, and we're going to see that. Fuel pressure sensor, fuel tank pressure, top of engine, fuel pressure sensor. It says FLP, maybe low pressure. There's your fuel injection pump. It's just a 2-pin. And that's the engine computer that's controlling that. So your powertrain control module. Yeah, and there's your fuel rail pressure. That's your high side pressure sensor. FRP is the designation. That is the PCM. So engine computer's getting all of this info. It's not being shared on a CAN network. So when this thing died on my brother, he said he saw a fuel rail pressure, that's the high side, down at 40 PSI. And what I told him is we could monitor the low side, these two guys up top, the low side pressure on the high side of the system, in that if the high pressure pump is not working at all, or is stuck open, say for example, we should see low side pressure in the high side of the system. And I'm interested to see that event. We may have to adapt a pressure gauge anyway, but I'm hoping we can just use scan data to give us a guide as to whether the low side pressure reading is accurate. I want to unplug this pump. Let's go into the hood. High pressure pump, it's right here. This is the solenoid for it. I hate to do this without recreating a problem. You never want to start unplugging things, but I need to know. Okay, so what I'm interested in is what my high pressure does when I electrically unplug the high pressure pump. Okay, high pressure pump. You see my rail pressure is now at 62 PSI. So that doesn't match. That doesn't match like my low side pressure number, as my brother said, never changed. It never changed. It should still be able to run. It may not. I've had other cars be able to run on the low side pressure alone. It looks like maybe this one's not gonna do that for us. But I don't like that my low side pressure is never changing. we're showing 62. Fuel pump percentage here is showing 19%. I'm looking for that command to increase. Definitely have an issue with this low side fuel pressure reading not ever changing. So there, it went to 101.5 for a second. Okay, so we're not going to be able to do the test I wanted to do, which is to use the high side pressure to give us a reading on the low side. That means what I'm going to do while we're waiting is I need to adapt into the low pressure side of the system. This is my low side pressure sensor right here. And so we can do some electrical checks on that. I'm curious, I'm gonna do it. And I might be screwing myself here, but I always hesitate to start unplugging things whenever you're trying to get a car to act up. But I wanna know why that data parameter is never changing. And I'm reading 4.82 volts on that sensor. So that parameter right there, there's pressure and voltage. If I unplug this, that should go to 5 volts if they use a bias on this. So I'm unplugging the low side fuel rail pressure sensor. I just did. That went to 5. My voltage went to 5, but my pressure never moved. How strange. How strange is that? Plug that back in, reading 4.82 volts. I'm no longer gonna look at pressure because that never moved. I'm gonna now look at voltage. I'm gonna unplug the high pressure pump again. I mean, is that pump maxed out already? I would think I'd see a pressure change on that, and I'm not. That 4.82 volts on the low side. There's 101.5 indicating on the pressure side. Yeah. We're gonna have to put a pressure gauge on this. I'm gonna do it. Let's shut this off. So our low pressure side right now is showing 67 desired. So there's still residual pressure in there. Ideally, what we wanna do is crank this over without the pump running to depressurize the system. But I don't know, we'll see what we can do. So here's your depressurize the system. Wrap a shop rag around it. Depressurized. This kit is so awesome. Here, plug this company right here. FPT 290. Okay, now I need one for my pressure gauge. This one's a little bit overkill, but we'll just use that guy. And then the end of this, it has adapters, so I can use this on any of my existing fuel kits. See the design, so that's the actual one for my gauge. There's the one we're gonna use. So this then goes here, and then my pressure gauge goes here. Cool. I could also plug in, if I wanted my extra one to bleed this out, really that's what I need to do. I wanna plug in this. This is way excessive amounts of hose, but this gives me my bleed so I can get all the air out of this. So that's the plan. All right, starting to back up. Oh, why is that dropping? So the fluctuations, what you would normally see, just from a high pressure pump, back feeding back into the system. Let me bleed some of this air out. Watch yourself. Okay. Just wanted to bleed pressure out. Yeah, that doesn't look good. This is gonna end up being a low side pressure problem. But why is my data parameter not showing me that? Yo, check this out, Danner. We got a problem. This is a low pressure problem. You were right in your suspicions.
Oh, what the hell is that?
Not good. Look at what, but here's the thing, right? Like, why is the pressure sensor not showing me that? And why are we stuck at, well, we're stuck at 109 because my voltage of my low pressure sensor never moves. And it should be.
When you unplug it, what does it do?
The low pressure sensor?
Yeah.
This will jump to 5.
No, but does the pressure change
I don't
in
know.
the PID?
I didn't, here, let's do it. I'm plugging the low pressure sensor now. Yeah, that went up real high. Here's your fuel pump duty cycle went to 31%. You know, it's normal to see those kind of fluctuations because that's what they're doing. The high pressure pump dumps back into the low pressure side of the system to control pressure. But yeah, I can clearly bring my pressure up mechanically back on this, Caleb. You know, we're hovering between 70 and 80 psi. My low pressure voltage is at 5. My fuel pump percentage is at 31. Watch, stay here. When I plug this sensor back in, plug in the low pressure sensor back in, you'll see it on the scan data. It's going to drop to 4.82. Right?
Now, yeah, and then it started decreasing your fuel pump duty cycle,
right?
And bringing you back down.
So it's like it can control the pump, and I'm wondering, is this really just an effed up fuel pressure sensor on the low side? I need to see it do it now. I need to see what that does. It shouldn't be like that, I don't think. All the flowchart stuff was telling you to make sure your low pressure was at least 45. Like when I was scanning through the flowchart, it was telling you to make sure that low side, it said, is it above 45
sometimes
PSI?
It kind of sticks kind of nice, you know what I mean?
Mm-hmm.
And then other times it's, I don't know, I've never instrumented one to know.
Well, I know fluctuations are normal.
Yeah, but like the 30 to 35 one or the 40 to 21?
Yeah, I don't.
You know what I mean?
I'm with
like,
you. I'm with you.
Like, look, it just.
I saw
hey,
the,
just.
and
like,
I saw the literal.
that would make sense to me, but not like a
Not
25-pound swing. I
mean,
think.
unless the reason why is we're having that big swing is because the computer's controlling the fuel pump duty cycle at 19. See, doesn't match here because my desired pressure on the low side is 85, and our actual is 35 because our pressure sensor's messed up. This might just be a faulty pressure sensor.
Because if I don't know, but why would, I don't know.
Well, because your low side desire is 85, the computer thinks it's at 109, and it's issuing that command of 19%.
Which would be keeping it low because it's probably trying to drop it.
It's keeping it low. This command of 19% is why our pressure's low. Because if I unplug it, that goes to 30% and my pressure comes up. Yeah. And that's based on that signal.
When you unplugged that thing, it only went up to 109.3.
Did that change?
It went up 310.
I didn't see that.
I saw
this never moved. The 4.82. Oh no,
this went to 5 volts.
Correct. Yes.
This went to 109.3 is what I thought I saw.
Mm-hmm. I'm pretty confident that voltage shouldn't be 4.82 volts and fixed. It should be fluctuating. We should see
that. We're seeing
we should see fluctuations. We're not. All right, go handle your customer. I'm going to do some voltage measurements on that while we're waiting. So that's my signal wire. I'm reading 4.8 volts on that wire, and we see some pulsing in there. I'm going to move over to the next wire. This is the middle wire. 0.02. That's my ground. There's my 5-volt ref. I don't want to see that kind of pulsing in the reference circuit, but I do have peak detect turned on too. Yeah, so ignore that stuff. Going back to my signal wire. 4.8. That's what scan data is showing me. So what I need to do is exercise the pressure in that low side. I should see changes here. Let me see if I can do that. We're dealing with a pressure sensor problem, I believe. I'm not totally sure yet, but any pressure sensor, it doesn't matter we're working on an unfamiliar system, a pressure sensor is a pressure sensor. 5-volt ref signal and a ground. Chapter 8 material. This pressure, we need it to change so we can change signal voltage. What does voltage do on a pressure sensor? It changes with pressure. So I'm just interested right now in changing pressure and see if I get a reading change on the pressure sensor itself. This is the actual measurement of 4.8 volts. That's what the scan tool's showing us right here. This 4.82 volts and actual is 4.83. That's our number where we are here. So I'm gonna shut the car off, turn the key on. Pressure is higher. Guess what? Never changed. 4.82 volts. It's the same. It's fixed. 45 PSI steady. Let's see if that'll increase when I crank it. Yep, went up to 90 PSI. Never changed. This is a faulty low side fuel rail pressure sensor. However, we never saw the situation. Do you know what I mean?
Yeah.
But look how low our pressure is. It's very possible that that sensor, if I heat that sensor, that's what I need to do. It's kind of sketchy to think about heating a fuel pressure sensor, but we're seeing a voltage right now that isn't causing the problem. I'm wondering if that voltage rises, not 5 volts, because 5 volts, of course, that's the highest voltage, but the computer recognizes 5 volts as a fault and it's gonna run in a default strategy. So I'm wondering if only a couple more tenths of a volt higher in pressure would be enough to make that drop down so low that our GDI high pressure pump is starving for fuel, and that's why we're seeing everything that we were, that's why my brother was seeing everything he was seeing. I wanna try to prove that. This is a faulty low pressure sensor right now. I'm just surprised that it didn't have codes related to this. This is interesting. Danner's gonna like that. Okay, tap test. We're gonna watch our voltage on the scan tool while I'm tapping on that, and then we'll watch our pressure. So I'm just gonna tap gently on it. Gotta watch that positive battery terminal right there. See if that makes a difference. No. All right, so hope these numbers make a little bit more sense now. So this 4.82 volts to the engine computer on its ROM lookup table is 109.1 PSI. Our fuel pump percentage right here is one that's the command to put us the desired 85.6, and the fuel pump percentage is one that it is actuating the pump to achieve that 85.6. The problem is we're at 109, it never moves. And so this is gonna be a lower than normal fuel pump percentage command, which is why our low side pressure is lower than normal actual, because the pressure sensor isn't reading properly. That's what's going on here. Unfortunately, I'm not seeing the actual issue, but I'm gonna tell my brother at this point that we're gonna put a low pressure sensor in this. I believe that what happens is this voltage is gonna climb, this 4.8 volts is gonna climb just a little bit. And if it climbs any higher, it's gonna make this situation even worse, because the computer's gonna issue an even lower duty cycle command. I think that's what's going on. And then with a lower issue duty cycle command, then that pump's gonna drop, the low side pump's gonna drop even further. Let's see what this looks like on a rev. And the voltage is never changing on the scan tool. I'm not looking at the scan tool right now, but I'm pretty sure that that's what's going on. That 4.82 volts, it's not moving at all, and pressure's all over the place. Absolutely. Unfortunately, I'm not able to show the actual condition, but I'm definitely calling the low pressure sensor. I was trying to think of how to raise that voltage a little bit. Obviously 5 volts is a default. Fuel pressure goes high when I unplug it. I hope that makes sense what I'm thinking about. If we could get this voltage to go to like 4.9 volts, that might be where this problem then becomes so low on the low side that it starves the high side. Danner, you got a heat gun?
Maybe.
I don't like the idea of a heat gun with fuel, but and I don't want to melt it. Okay, we're heat gunning it. While we're watching our pressure gauge, while we're watching our voltage on the scan tool, I just want to prove the fault, that's all. I know it's faulty right now, the sensor, but I want to prove the temperature fault, where when you run it, it gets hot, it acts up, shuts off, stalls, fuel trims go way positive. This little heat gun's awesome. Perfect for us right now. Oh, we had a voltage change. Just momentary. Down to 4.81. We're getting some fluctuations. There we go. There we go. Yeah. Check that out. Look, my low side pressure's coming down too. Okay, so it's starting to read properly with heat. Cause see the low, oh, this is sweet. Oh, big change, big change. So heat is like making the sensor work properly. And now our actual low side pressure, yeah, look at the fuel pump duty cycle increased and our pump pressure increased. Oh, what a great capture. We don't even have to come back. So our fuel pump percentage went up to 22.4. The overall result is we're near normal pressure now on the low side. Not near, I'm sorry, that's wrong. The desired is still 85. It's saying actual is now 85. So we're still not quite right because our actual is not 85, our actual is like 45. So this is still skewed. Even though the sensor's now working, it's still skewed high. And now if I take that off, let that cool down for a second, let's watch it. We put some water on it, kind of cool it down. Just trying to cool it. Yeah, look at that voltage rising. Car's stumbling. Rail pressure, let's watch it.
Watch your arm.
Oh, big change. That's just cooling it down. I still didn't see our high pressure system being affected by that, like Danner described, but we're back up to that number. That's good enough for me. That is awesome. Danner, can I have you for like 5 minutes so I can go? I'm gonna make a call on this. Before I forget, when Danner comes over here, this 3.8 volts, like that's in this range in here, and it's showing 85 PSI, I'm saying that once the pressure sensor's replaced, we will see, if you guys remember, we were hovering around 40, 45, not 85, right? So that means the 3.8 volts is correct as far as what the pressure should be, but the equivalent to actual pressure is still off, even though the sensor started working. I hope that makes sense. I'm saying the 3.8 volts, when we're done, we'll still see that 3.8 volt. The difference will be our low side pressure gauge will be at the 85 number that the desired is. And so the sensor's still skewed. So that's what I'm gonna tell Danner. My brother's ordering the pressure sensor right now, and as soon as he gets off the phone, I wanna rehash what we see right here. And then we're gonna put a new pressure sensor in this. And we never saw the high pressure fault that my brother described, but I believe 100% that at times this low side pressure is getting so low from the skewed sensor that it's affecting the high side of the system, because it's a delivery problem to the high pressure pump. All right, I'm confident in this fault. So our pressure is lower than normal.
Yes.
Our pressure is lower than normal because our fuel
voltage
rail,
is
our
wrong.
voltage is too high, right?
Yeah.
So here's what we did. If you follow this is where I started heating it with a gun. So we're at 4.82 volts here, and then the sensor.
So that would make sense. The hotter it gets, the worse it gets.
Well, actually, the better it got, the hotter it got.
Oh, really?
Yeah. So this is as I'm heating it, where we start dropping. You see the pressure dropping too.
Yeah.
Right, and then I'm down in this area about 3.8 volts, and you see the duty cycle rise too.
Yep.
On the low pressure pump, and now our desired is matching 84.9 to what it wants. Right. Our actual pressure is matching desired. However, that
It's
gauge
not showing you that.
it did rise. It went up to like 45 and hovered around.
Okay.
But and so we're still skewed as far as relationships go between actual pressure and what the pressure sensor is showing. Even though it's good here, it's good. It's
Yeah.
still not.
Yeah.
When we're done, it'll still be 3.8 here and 85 here, but our pressure on the gauge will be 85 too.
Yeah.
So what I think is happening is when, and we just weren't seeing it, at times, this number up here, that 4.82 volts, if that climbs at all, if that 4.82 or 109, if this would climb at all any higher, the computer's then gonna lower the duty cycle even lower.
Oh, so you think it's failing the other way?
I think it's failing, yes, and
Okay.
I am not seeing that now.
Yeah, for sure.
And that's going to starve that pump. We're already starving the high pressure pump with fuel.
Yeah.
And if that number,
that's probably why you're getting so much of a fluctuation.
Correct.
Without 80 pounds holding you back.
that's right.
Yeah.
That's why that needle's all over the place.
Yep.
So
Damn it, I wanted you to see the high pressure
Well,
go up to
I did too.
1100
Look, I did-
commanded and 200 and
I did too, but the fact that we were able to use a heat gun and do that to it, and then watch, this is me squirting it with a bottle of water
nice.
to cool it back off.
And went back to the 109.1.
Yep, and then you see exactly the duty cycle dropping down too.
Yeah.
So then my actual pressure actually
Dropped
dropped as
down
well.
too.
So I don't think we needed to see that.
No, but it would have been nice to show because someone looking at a scan tool would see their high pressure go into 200 and see their low pressure at 109.
Yep.
And call the high pressure pump.
Yep. Okay,
the
so
same
listen,
engine in it.
this is one where we need to tread carefully how we sell this job. It absolutely 100% needs that low pressure sensor, but we cannot promise this customer that high pressure pump didn't have any damage.
Over there.
This is 100% a pressure sensor fault.
Nice.
Because I was able to cycle the key, get the low side up to 100 psi on my gauge, cranking it never moved. Stayed at 4.83 volts on the pressure sensor at 100 psi, and it stayed there at 25 psi. Where we are now.
Yeah,
30
when you
PSI.
unplug it, it only went up to 109.2.
Well,
or
when I
3 or
unplug it
something.
though, the problem with the really?
It did.
Okay.
I
The
watched
prob-
that go to 109.3.
The problem with the unplug it test is that's 5 volts, and the
Yeah.
computer knows there's a fault, and
Yeah,
then
it'll-
resorts a default strategy on the pump itself.
That's why our pressure went up.
Correct.
Didn't matter. Yep, makes sense.
So, but I still think that 4.82 volts at times is going 4.83, 4.84, 4.85,
Yeah.
and it's enough for the duty cycle to drop enough over here to lower that pressure even more, and then we
down to
start
20,
starving.
and then you're
we
never
start
going to be
starving
able
the
to do it.
pump.
The volume won't even be there
That's
to
what
run
I think.
the car.
That's what I think you saw, and I think we'll be okay with a pressure sensor only. I am 100% confident this needs a low pressure sensor.
Yeah.
I can't say I'm 100% confident on the pump, but I'm pretty confident we'll
Yeah.
be okay. Cool, man. And I'll leave all this connected then.
Yeah, just leave it all connected.
All right, perfect.
And then take
And
your
we'll see you guys in the next shot, even though it will be Monday. Okay, I'm back on the Ford. Caleb's not here. I apparently developed another illness amidst the 2-week cough that I had, and I got everybody sick. I had a fever this weekend too, and Caleb has it now, and you can hear it in my voice. It's been awful, but I'm outside too, and so I don't contaminate my brother anymore. But this has been repaired. Let me show you where we are. Just a shot of the old sensor. Shot of the new sensor back there. It's our actual pressure. See, it's like 60 to 65 average, probably 55 to 65 at times. Pretty big swings in that, but that's that high pressure pump dumping in there. Remember where we were before? We were down hovering around 25 at times, 25 to 35. Let's see what scan data shows. All right, I don't know if my brother cleared the codes out of this. I'm hoping that he did. I wanted him to. Lost comm with active grill. Okay, good. He did. So that's the only code that was in there from before. There's our low side pressure, low side desired. One of the things about this, my brother called me and he told me too, he's like, hey, you know, these numbers look good. You see how much higher our fuel pump percentages here too. We're at 27%. We were at like 19% before. But one of the things that my brother had said is that, hey, you know, Paul, it doesn't quite match. You know, we're at like 78, 79, 80 PSI on the low side fuel pressure. In the actual, you know, at the same time, kind of give this a range here. Yeah, maybe, you know, 60 to 65, 78 to 80. So we're like 15 PSI off. And I called my friend Brian Pollock and I'm like, hey, Brian, have you seen this before? Like how much are these close to each other? And he told me all the ones that he's seen, they are off. They will not, the actual pressure will not be the same as what you're reading on the scan tool. And he said Ford offers an IDS test with the factory scan tool, and you use a pressure transducer and you do these kind of checks, and he said they all fail. So there's something going on there. I'm not gonna worry about that. I know it's not kind of the smoking gun we're looking for, like exactly the same pressure, and this would bother me. Had I not talked to Brian, I would feel like, well, you know what, maybe we should be thinking about getting making sure that this is a factory sensor. You know, I asked my brother, he said it was an OEM, but he's not sure, OEM equivalent, but he's not sure if it was an OEM sensor. I'll have to ask him again. But that'd be the only other thing that I would say, calibration of that sensor can cause this. But to hear Brian tell me that he's seeing that discrepancy makes me feel a lot better. You see how much higher our fuel pump percentage is, the duty cycle. You see our low side voltage moving around, fluctuating. Let's change this range. Let me snap it a couple times. We're gonna call this a fix. Let's just snapping the throttle. Just at a little bit higher RPM. It's like 2,000 RPM roughly. So I'm showing like a much steadier signal or pulse on the low pressure side. About 65. I think scan data would be a lot more steady. Let me reset this min-max scale if I can. It's weird, it's not letting it reset all the way. At minimum 60. It's just moving 75 to 85 when I'm really closer to 65. Like I said, had I not talked to Brian, I wouldn't be too happy about that number. And the only other thing that would make it do that would be, you know, a 5-volt reference problem to the sensor. If your reference voltage is low, your sensor is going to be skewed. Or if your ground circuit is off, if you have higher than normal ground voltage, your sensor can be skewed. Other than that, you're pretty much talking about a sensor issue, and it's really a calibration issue of the sensor. But I'm anxious to hear your thoughts on what you guys are seeing. Let me let it idle now. It's big swings from the high pressure pump dumping back into the low pressure side of the system. Completely normal. It's weird to see that with the idle fluctuations that are much higher, that the scan data reading of the sensor is much smoother. Just very strange characteristic. I would think it'd be the opposite. So it's like there's some conditioning going on here on this signal circuit. Maybe in part because the high pressure pump dumps back into the low pressure side of the system, and they're doing calculations on the low pressure side. They have some type of filter built in, and that in itself would explain maybe the skew in our two pressure readings. This is fixed. The car runs beautiful. You see our low side pressure voltage too is 3.5, not stuck at 4.82 like we were before. If I snap the throttle, it's going to change too. Those are going to be mirrored with each other. The pressure's up top now. Sorry, voltage is up top. Snap the throttle, you see the changes in pressure, changes in voltage correspond with changes in pressure. None of that we were seeing before. Just a simple faulty low side fuel pressure sensor. Chapter 8 material being applied to something new. See what I mean? See how much the fluctuation is, and see how little the fluctuation is in the voltage and pressure on the scan tool. Now when I raise the RPM and get a more steady pressure, then I start to see pressure and voltage changing even more. Even though the pressure gauge is very steady at 65, we see scan data showing us an increase in fluctuations. It's so strange. But again, look at that fuel pump percentage, 27.2. We were around 19 from what I remember before. So look for that, guys. Low pressure actual that doesn't quite match scan data. Be anxious to hear your thoughts on what you guys are seeing. But it was easy to pick out when the failure was there because we had no low side pressure changes whatsoever. It was stuck at 4.8 volts. And you see now we are not. And what that was causing again was the fuel pump percentage duty cycle was being decreased because the computer was trying to reduce the high pressure that it thought it had. And what it was actually doing is starving the high pressure pump of fuel, and that was causing all of our issues. So my brother did say he caught the car doing it, and he didn't see the 4.82 volts climb like I thought, where the computer would take even more fuel away on this number, this 25.9, this fuel pump percentage number that we're looking at right now. My assumptions were the computer would take even more away if this low pressure voltage that we saw at 4.82 volts before was increasing even higher. And my brother said he got the car to act up. He had the high pressure side drop to near 0 or like 40 or something before the car stalled, but none of the other numbers had changed. And so the only thing I can think of there is maybe that low pressure was so low, you know, down at 25, that it was allowing that fuel to boil in there, because it would only do it when it was hot. And if the fuel starts boiling, then it's going to aerate, and then that's going to starve the high pressure pump. And I think maybe that's what was going on there. So anyway, pretty basic one here, guys. Not too complicated. Hope you learned something from it. Look forward to your comments. Sorry for the nasally voice here at the end, but we are done. Thanks, guys. I'll see you next time. So Brian Pollock, as I'm talking to you guys, just sends me this Ford service info. They updated their service info on these cars for this condition. This is awesome. Brian, you're so awesome, man. Ford Fusion 1.5, that's us. Follow this row right here. And it shows the fuel rail pressure sensor PID 61 to 93 PSI, where at the same time your external pressure gauge is going to read 46 to 78. So there's your skew right there. It's about 20 PSI off, 15 to 20 PSI off. That's exactly what we had. My external gauge, you know, I'm hovering 60 to 65, and my scan data is hovering around 80. So there you go, those two right there. Freaking awesome, Brian. Thank you so much. Are you gonna put a compilation of me coughing in this one? Hey Danner.
You break it yet?
No, but I'm putting a fuel pressure gauge on this. Where's the rest of... All right, so I'm just going in to the doctor. Damn. I'm sorry. I promise I'm not getting you guys sick.
Like, here I go. What the heck's going on around here?
What's up, man? What are we doing?
Oh man, my wife has the flu now.
Oh no, oh no. We have footage of our last video.
With me coughing?
And me coughing and being like, I'm fine, I've had this cough for weeks. And here I got sick while I was trying to get rid of this cough, and I got steroids for my cough. And then I had a fever like the next day, and then I got everybody sick. Caleb's sick, my daughter's sick, I got Danner sick, I got everybody sick.